Welcome to class. Grab your book and pen and get ready to learn. You're welcome to class. Today we'll be looking at approximations or rounding off. Another word to use for approximation is to round off, rounding off. To round off means to make a number simpler and easier to manage. For example, 22/7, that is pi, is equal to 3.142857. This is a lot of decimals, so we can choose to make this number simpler and easier to manage by rounding it off, like to 2 decimal places. Then in that case, I will say this is approximately equal to 3.14. 3.14 is not exactly equal to 3.142857, but it is approximately equal to it. And that is why I want to quickly talk about these signs. This is exact equality. This or this is approximate equality. So anywhere you find this sign or this sign is telling you that it is approximately equal to the other side of the question. There are 3 areas of approximation we'll be looking at in this lesson, and they are approximation to a specified place value, approximation to a specified number of decimal places, and approximation to a specified number of significant figure. It is possible to approximate a particular number to these different specifications. Let us look at examples to drive home the lesson. Let us learn to approximate 382.853 to the nearest whole number, hundreds, tens, tenths, and thousands. We know that the digits from our left before the decimal point are whole numbers, while the ones after the decimal point are fractions. So when we are rounding off to the nearest whole numbers, we have to consider the whole numbers. In this case, in 382.853, 382 is the whole number. We see that 382.853 is approximately equals to 382. That is the whole number. Then you will have to look at the digit immediately after the whole number, which is 8. If the immediate digit is up to 5 or more than 5, it will be rounded up upon the whole numbers. But if the immediate digit after the whole numbers is less than 5, it will be rounded down as insignificant. So let us see what I do here. This is 8. 8 is the immediate digits after the whole number. So I will round it up upon the units as 1, and it will be added to it, so that we have 383. In that way, we can say 382.853 is approximately equal to 383 to the nearest whole number. Let us look at the other areas of the example. We have to round off this same number to the nearest hundreds. So we have to remember our place value. This is units, tens, hundred. So this is my 100. 3 is the digit that is my 100. So I want to round off to the nearest 100. For 3 to be 100, there must be tens and units. So in the places of tens and units will be replaced with 0 and 0. But I won't just leave it like that. I will look at the immediate digits after the 100. If the immediate digit after the 100 is up to 5, it will be rounded up as 1 upon the 100. So this is up to 5. So I will round it up upon the 3. And you will call the 1 added to it. And that is 400. Which means that 382.853 is approximately 400 to the nearest hundreds. Let us look at the third part of that example. Requesting us to round off this number to the nearest tens. The digit that represents tens is 8. So, for this number to be in its simplified form, so I will write 3, I will write the 8. For 8 to be tens, that means there must be units. So in the place of units, I will represent it with 0. I won't just represent it with 0 alone. I will look at the digit immediately after the tens, and that is 2. When the digit immediately after the tens is up to 5, it will be rounded up as 1 upon the tens. But when the digit is not up to 5, it will be rounded down. So it's not going to have any effect on the answer. In this case, the digit immediately after 8 is 2. So this will be rounded down. It won't have any effect on that answer. That means 382.853 is approximately equal to 380 to the nearest tens. Let us look at the fourth part of that example. We want to round off 382.853 to the nearest tenth. The digit in the tenth place value is 8. Before we round it off, we will have to consider the digit immediately after it, which is 5. When the digit is up to 5, it will be rounded up as 1 upon the tenth, so that we have 382.8. Considering this 5 that is rounded up as 1 upon it, we just drop the 1. So we have 9.283. That means 382.853 is approximately 382.9 to the nearest tenth. 382.853 to the nearest thousands. The digit in the thousandth place value is 5. So we write 382.85. We won't just stop at that. We will consider the digit immediately after the thousandth. If it is up to 5, it is rounded up upon the thousandths. But if it is less than 5, if it is rounded down. 3 is less than 5, so it is rounded down. So it won't have any effect on this answer. So our answer is just 382.85 to the nearest thousands. I hope you understand this. For your practice, round off 3.142857 to the nearest whole number, the nearest hundreds, tens, and thousands, and let me have your answer in the comment section. Welcome to the other part of approximation and rounding off. In this part, we'll be looking at approximation or rounding off to a specified number of decimal places. Decimal places are very easy to know. To know the number of decimal places a number is set to, all you have to do is to count the number of digits after the decimal point. For example, pi. Pi is 22 over 7, which is equal to 3.142857. 3.142857. To know the number of decimal places this is, we have to just count the number of digits after the decimal point. In this case, this is a number to 6 decimal places. So this number can be rounded off to lower number of decimal places. Let us look at this example. Let us round off 3.142857 to 2 decimal places and to 3 decimal places. For the first example, to round off to 2 decimal places, 3.142857. The digits in the first 2 decimal places are 1 and 4. So I'll write 3.14. I won't just stop there. I will look at the digits immediately after the second decimal place. If that digit is up to 5, it will be rounded up upon the second decimal place. If it is less than 5, it will be rounded down as insignificant upon the approximation. In this case, this is 2, not up to 5, so it is rounded down. It will not have effect on that answer. So that I can say 3.142857 is approximately equals to 3.14 to 2 decimal places. Now let us round up to 3 decimal places. The first 3 decimal places here are 1, 4, and 2. So I'll write 3.142. I won't just stop there. I will consider the digit immediately after the third decimal place, which is 8. If the digit is up to 5, it will be rounded up upon the third decimal place. If it is less than 5, it will be rounded down as insignificant. In this case, the digit after the third decimal place is 8, so it will be rounded up upon these 2 as 1. So I'll add it here upon it, so that I have 3.143. So 3.142857 is approximately equals to 3.143 to 3 decimal places. 3 decimal places. For your practice, round off 17.4061 to 1 decimal place, 2 decimal places, and 3 decimal places. To determine the number of significant figures a number is written to, we have to start counting from the first digit that is not 0 on our left. For example, if I have a number like 1432.89 is to 6 significant figures. Because from my left, the first digit that is not 0 is 1. So I'll count 1, 2, 3, 4, 5, 6. So this is 6 significant figures. Another number like 0.0512. For this kind of number, to know the number of significant figures, we have to start from our left and start counting from the first digit that is not 0. The first digit that is not 0 from my left is 5. So I will count 1, 2, 3. So a number like this is to 3 significant figures. The first 2 zeros preceding 5 in this case are not significant. Their significance is just to mark the number of decimal places and not to mark significant figure. I hope you understand this. This is another example. We start counting the number of significant figure from the first digit from our left that is not 0. The first digit from my left that is not 0 is 1. So I'll count it 1, 2. Am I going to count this 0 embedded with, between non-zero numbers? Yes, I will count it because I already started counting number of significant figures. So this is significant, unlike this. So in this case, this number is 4 significant figures. Round off 14.826 to 3 significant figures and to 4 significant figures. 14.826 is a number in 5 significant figures. So to round off to 3 significant figures, I'll count the 3 significant figures, which are 1, 4, and 8. So to round it off, I will write this 14.8. I won't just leave it like that. I will consider the digit after the 8, after the third significant figure. If that digit is up to 5, it is rounded up upon the 8. When that digit is less than 5, it is rounded down. So in this case, this 2 is rounded down. It won't have, if any, effect on my answer. So 14.826 is 14.8 to 3 significant figures. 14.826 to be rounded to 4 significant figures. Let us count the 4 significant figures. They are 1482. We won't just write 1482. We will consider the digit at the back of the 4th significant figure. If it is up to 5, it is rounded up upon the 4th significant figure. If it is not up to 5, it is rounded down. So in this case, 6 is up to 5. 6 is up to 5 and even more than 5. So it will be rounded up upon these 2 so that we call it 14.83 to 4 significant figures. Let us look at more examples of significant figures. Let us round off 0.00719 to 1 significant figure and to 2 significant figures. In this case, this is a number that has 3 significant figures. The 3 significant figures are 7, 1, and 9. So to round off to 1 significant figure, the first significant figure is 7. So I won't just write 7. I will consider the digit immediately after it. The digit is not up to 5, so I'll round it down. It won't have any effect on my approximation. So I will just have 0.007 to 1 significant figure. The second example. We want to round this up to 2 significant figures. So, this is the first significant figure. This is the second significant figure. I will just write the second significant figure. I will consider the digit after it. The digit is more than 5, so it will be rounded up upon the 1 as additional 1, so that the answer is approximately 0.0072 to 2 significant figures. For this kind of question, when you are asked additionally to round off to 1 decimal place, it is not a problem at all. 0.00719. This is 5 decimal places. So the first decimal place is 0. You want to round off to 1 decimal place, and the first decimal place is 0. You won't just write the 0, you will consider what is at its back. If it is up to 5, it is rounded up upon it. If it is less than 5, it is rounded down. So this is not up to 5, it is rounded down. So for me to write my answer here, I will say 0.00719 0.0719 is approximately equal to 0.0 to 1 decimal place. Isn't this wonderful? If you have to write this to 2 decimal places, let me give you that assignment. Give me the answer in the comment section. Thank you for watching. Please subscribe to our channel for more interesting lessons.